Welcome back to Easy Academic. In this installment of the linear algebra series, we'll be going over the ideas of row picture and column picture. And so what row picture and column picture aim to do is provide a means of interpreting the general expression AX equals B, where A is a general matrix and X and B are either matrices or vectors. And so you'll remember from the matrix multiplication series that if A is a M by N matrix, X must then be an N by L matrix, and B would be an M by L matrix. We need to figure out a way of interpreting what this matrix multiplication would look like. And so first we'll start with row picture. Row picture allows us an interpretation to view the system AX equals B one row at a time. And so what row picture aims to do is be viewed as a series of intersecting lines and planes. So generally we denote this as, for example, A11 times x1 plus A12 times x2 for all values in A and X. So A1n xn equals B1. So this is for the first row in A for all the values in X and for the first row in B. Similarly, we'd have A21 x1 plus A22 x2 for all the values in A2. And we would get B2, which is the second row in B. And we do this for all values in A, X, and B. So specifically, we go through A and B row by row. We multiply every row in A by the vector or matrix X, and we equate it to the value B. So this might be a bit confusing, so let's work through an example in 2 dimensions to better intuit this. So say we have a matrix A, which is 2 by 2, and we set it equal to 2, -1, 1, 2. We set our matrix X to just be equal to x1, x2, and let's say our B is equal to 3, 8, and we want to solve for the x's here. So an important thing to note is that when we have this representation here, what we're solving for is x. So that is the matrix X. We want to solve for all of the entries, x1, x2, up to xn. So if we write out the row picture interpretation of this, what we have is A11, which is 2, times x1 plus A12, which is -1, times x2 equals the first row of B, which is 3. Similarly, we have A21, which is 1, times x1, plus A22, which is 2, times x2, equals the second row of B, which is 8. And so you'll observe this is a simple series of equations. So we have 2 equations and 2 unknowns, and we can simply solve for either of the x's through either substitution or whatever method you find most appropriate. And so in this case, what we can do is we can rearrange for x1. So let's take this second equation and rearrange for x1. So we'd find that x1 equals 8 minus 2x2 by subtracting 2x2 from both sides. We can then take this value for x1 and substitute it back into the first equation. So we have 2 times 8 minus 2x2 minus, so we'll just distribute the negative out here. So we have minus 1x2 equals 3. Expanding this out, we have 16 minus 4x2 minus x2 equals 3. And if we take 16 over to the other side by subtracting both sides, subtracting 16 from both sides, we have negative 4x2 minus x2 equals negative 13. Finally, we have negative 5x2 equals negative 13, which implies x2 is equal to 13 over 5. Now that we have x2, we can solve x1 by substituting back into this expression. So we have that x1 equals 8 minus 2 times x2. And since we know x2 is equal to 13 over 5, we know that x1 is equal to 8 minus 2 times 13 over 5. This is equal to 8 minus 26 over 5. And if we convert 8 into fractional form, the denominator 5, we get 40 minus 26 over 5 is equal to x1, which is equal to 14. So we found that x equals x1, x2, and we found that x1, x2 is equal to 14 over 5, 13 over 5. Now we move on to column picture. What column picture aims to do is to represent the expression ax equals b as a linear combination of column vectors. And so we interpret this column-wise, as is implied by the name column picture. And so using the same example as earlier, let's show what we mean by this. If we use the column, if we use the matrix A, which is equal to 2, negative 1, 1, 2, we have x equal to x1, x2, and our same b equal to 3, 8. And we attempt to solve ax equals b. What we'll find is that 2, negative 1, 1, 2, x1, x2 equals 3, 8. So when we say we want to represent this as a linear combination of the columns of A, what we mean is we want to express this in this sort of way, where we take x1 and multiply it by the first column, and then we add x2 multiplied by the second column, and that linear combination will be equal to b. And so what we represent this as is some scalar multiple x1 of the vector 2, 1. So let's say this is 2, 1 multiplied by some value x1, and we then add the vector negative 1, 2, which would look something like this. And we add those two lines to get the vector 3, 8, which would look something like this. So we would find the scalar multiples x1 and x2 that would allow these vectors to add to 3, 8. So we can do this using a similar method to above, because in my opinion that's what's most intuitive. So if we distribute the scalars, we'd find that x1 times 2, x1 times 1, this vector plus x2 times negative 1, x2 times 2 is equal to 3, 8. We'd find further that x1, 2 times x1 minus x2 equals 3, and that x1 plus 2 times x2 equals 8. If we took the different approach of multiplying this equation by 2, or let's say by negative 2, we'd find that we obtain negative 2x1 minus 4x2 equals negative 16. And if we then added this equation, so 2x1 minus x2 equals 3, let's say we added that, we'd find that we have 0 minus 5x2 equals negative 13. And again, this implies x2 to be equal to 13 over 5. Substituting this expression back into either of these two will give us the value for x1. So let's take the bottom expression, 2x1 minus x2 equals 3, and substitute in 13 over 5. So 2x1 minus 13 over 5 equals 3. We find that 2x1 is equal to, let's convert this 3 into a fraction in terms of denominator 5. So find that 15 over 3 plus 13 over 3 equals 2x1. And this is equal to 28 over 3. If we then divide both sides by 2, we find x1 to be equal to 14 over 3. And then in total, x equals 14 over 3, 13 over 3, which is the same conclusion from the row picture interpretation. So if you found this video helpful, please like and subscribe to the channel. Be sure to write your comments if you have any questions, and stay tuned for the next episode in the linear algebra series.